Hello, this is Steve Larson, one of the editors at Hoard's Dairyman, and we welcome all of you to this webinar for your viewing. We're very pleased to have with us today Mike Van Amburgh, our presenter from Cornell University, and we're especially grateful to Merck Animal Health for their sponsorship of this webinar, which makes it free to all of you folks and others out there, and we're very pleased to have that. And right away, I will turn the meeting or the webinar over to Mike Hutchins, our host down at the University of Illinois, who will introduce the speaker this morning and get us going. Mike?
Very good, Steve. Well, welcome everybody online. We're pleased to have you online today. We're excited. We have one of the world experts, and in all honesty, in the area of calf nutrition and growth programs and heifer programs. And as Steve indicated, we're very pleased to have Mike Van Amburgh as our lecturer here today on this very important topic that we're going to be talking about, the long-term impacts of calf feeding. Mike grew up in Ohio and then went on and finished up his PhD at Cornell University, and they were smart enough to hire him back on their staff as far as that goes. Many of you know Mike Van Amburgh primarily because of his numerous writings and speakings around the world at this point. So you're well aware of his research areas, and is very heavily involved in the nutrition area, both not only in calves but in cows, heifers, in that area as well. Besides teaching a plethora of classes at Cornell, he also is heavily involved in the Dairy Fellows program, which is one of the unique undergraduate programs here in the U.S. He's been heavily involved in the Dairy Challenge program, and his teams have been quite successful at this point, and an advisor of their dairy club as well. So Mike, besides that, he last year, I think, Mike, you received 2 awards, which is very unusual from the American Dairy Science Association, one on teaching and one on research, and of course that's a very prestigious award as well. So Mike, we're very pleased that you could fit us into your busy schedule, and with that, we'll turn it over and let you kick off today's webinar.
Well, thank you, Steve and Mike. It's a pleasure to be here this morning, and this is a great honor for me to be part of this Hoard's Dairyman webinar. So the topic of the day is early life nutrition and management of calves and productivity. This is a topic, had you asked me 15, 20 years ago, would I be speaking about something like this, and I would have said you're probably a little bit crazy. But what's interesting is as we learn and as we understand, we're finding that this period of life is actually very important to set that calf up to be a more productive adult. And actually I'll expose a little bit more of that, but I think a lot of this has to do with some of the things that we know about fetal programming, which is much harder and much more difficult because it's hard to manipulate that, and I'll explain that as we go. So the overview of today's talk, brief introduction. I'm going to discuss what I'll say are the implications of colostrum, and I know for years we've talked about IGs, and they're vitally important, but as we begin to understand the calf and what mom is producing, we're beginning to realize that mom is trying to send some other signals to the offspring, partly through colostrum, partly through milk, to enhance her abilities. One slide on nutrient requirements, and we could spend a couple hours talking about nutrient requirements, how do we feed around weather, but in the interest of time, we're going to just do one slide and I'll talk around that. And then finally, we'll get to the real part of what we're here for, and that's the data that's being generated concerning pre-weaning nutrition and future productivity. So I have this rather bold statement up here on this first slide: colostrum is the foundation for functional change. Well, what do I mean by that? And we know that there are lots of compounds in colostrum that can affect development. And you know, for years and years and years, and rightfully so, we have focused on immunoglobulins and IGs to enhance the immune system, because we know that the calf is born basically without the presence of some of the maternal IGs. Well, where that led us is we got very focused on making sure that we had good passive transfer, and then we had good immune status, and we knew that had to happen because we want to reduce death loss, we want to reduce morbidity, we don't want to treatments. We want to, and that's actually part of the reason that we now heavily vaccinate or have good SOPs for dry cows and vaccinations and even vaccinating heifers, is to make sure that we produce good colostrum. As a physiologist, I would argue that IGs probably aren't really all that necessary. And that sounds like a really profound statement, but if you think about it for a minute, how many calves actually get enough IGs, right? And we know that we have greater death loss and there's more sickness, but a lot of them will survive. In reality, the calf can eventually produce their own IGs if they get exposure. And we know that this starts at about 4 to 5 days of age. And as they become more exposed to the environment, they produce their own IGs. Now, I'm not going to argue that we shouldn't pay attention to that, but there are some things. I think we got heavily weighted towards the IGs and forgot about some of these other factors. For example, we know there are things like insulin-like growth factor 1 and 2 that are expressed in high levels in colostrum. And there is a pretty rich body of literature that says that those compounds, those growth promoters, have pretty big impacts on gut development, right? And whether those get absorbed into circulation or not, still kind of undecided, but we know that they do help develop the gut. We know that when a calf is born, it can't digest lactose. It has to stimulate lactase development. Part of that, we think, comes from things like IGF-1. So the more IGF-1 we get into there, the faster the gut matures, the more gut development we have. And actually, given that the gut is the greatest or the largest immune organ in the body, that helps stimulate immune development by creating a better barrier to keep bacteria out. Lactoferrin is obviously a compound in the gut, or sorry, a compound in colostrum that creates local immunity by getting rid of some of the bacteria, by binding bacteria and killing them and moving them out. We can look at things like prolactin. Not a lot of data on prolactin, but from our perspective, it's a good candidate. Insulin is one that truly is interesting. There is a lot of insulin in colostrum, and I won't speak to this today in this webinar, but we now have pretty good data that says that the calf absorbs a significant amount of insulin from that colostrum, and it may very well be that the gut has glucose, insulin-sensitive glucose transporters that actually help move glucose from colostrum into circulation. So things like leptin, we know can be absorbed, we know can cross the blood-brain barrier, could have an effect on how the calf regulates intake and feed efficiency over time. The one that I'll briefly touch on here is relaxin. We know that relaxin is produced in humans, dogs, and pigs. In pigs, we know that influences reproductive development, right? And reproductive function is one of the things that we're most concerned about in our high-producing lactating cows. And it's interesting to note that in pigs, they figured out that the relaxin that the baby pig consumes in the first meal actually enhances reproductive function as an adult. And that led to this term, the group that figured out the relaxin effect. It's a group that works across the country, but they came up with this this term that they call the lactocrine hypothesis, and I really like it. The concept is not new. The concept is many years old, but the term is quite new. I think it helps us understand maybe some of the things that mom is trying to do. Maternal programming extended beyond the uterine environment to ingestion of milk-borne morphological factors. In this case, milk can include colostrum. Right? And in pigs, we know that maternal relaxin from milk stimulates the development and differentiation of the uterus, and that mediates the effect of estrogen on the growth of the uterus. And the current data would suggest that as they do this right in the first meal, those pigs are more reproductively efficient throughout their life. All right? And that's a tremendous impact from just the first meal. So that leads to all these ideas that what we do in that first feeding and what we get from colostrum is really important to set up mammals, in this case pigs, but the idea that that works in calves is quite apparent, and I'll show you some of that data here. So we have the study that was conducted in cooperation with Agway many years ago. Agway was developing all sorts of lines of feeds for calves, new milk replacers, new starters. We wanted to try this out. We actually did this on a farm where Sam Ledley, many of you are familiar with, was the calf manager at the time. This was prior to his current career. And very meticulous in his record keeping. We did all sorts of things. We had 400 calves, 3 different levels of milk replacer, 2 intake levels, a couple different starters, followed the calves through breeding. The most important thing was IG status, right? But and when Sam had finished analyzing the data and he showed it to us, it was obvious that the calves that had a failure passage transfer had about 50% less feed efficiency. And we didn't understand that at the time, you know, and since the only thing we measured was, you know, failure passage transfer, we assumed this all had to do with the immune system. But when we looked at dry matter intake and we looked at the incidence of respiratory or diarrhea or antibiotic treatments, there was no effect. So the IG status or the failure passage transfer was independent of any health effect. But what we did see is that the calves that didn't have enough good passage transfer had about 50% less feed efficiency. All right, we didn't know what to do with that. I think we know what to do with that now. It says that there's other things in colostrum. The calves that didn't have or had poor transfer of IGs also probably had poor transfer of some of those other compounds that we're talking about in colostrum. You see the same kind of thing in this study where they looked at colostrum intake and long-term performance. And, you know, the primary function here was 2 or 4 liters of colostrum at birth. These were brown Swiss calves. And then after they gave them that colostrum, they commingled them into the same management and then just measured their performance. And not a large number of calves, but I think the most dramatic thing is the half-pound difference in average daily gain prior to puberty. All right, so this 2 or 4 liters of colostrum actually impacted growth rate all the way to puberty. Half a pound a day is a tremendous amount, and of growth. And I think the interesting thing here is that from the data, we can't tell whether it was a change in feed efficiency or a change in feed intake. But what we do know is that there is that half a pound a day difference in gain. We can see a significant difference in survival, even though we don't have large numbers, and those that survived through the second lactation made a couple thousand pounds more milk. So the implication here is that the level of colostrum that the calf received immediately after birth impacted growth rate prior to puberty, impacted survivability through the second lactation, and actually enhanced milk yield slightly, but, you know, not a big effect. The big effect is growth rate, feed efficiency, and long-term survival. But again, what happened in the first couple hours of life had long-term impacts. Now, in this particular study, just to add to that, that concept, we see source of colostrum replacement, right? And this was a study conducted at Virginia Tech by Colleen Mallory Jones. And what they were doing is they were testing the effect of colostrum versus colostrum replacement. And the real question was, do they get, does the colostrum replacer provide adequate IGs? And do they get good passive transfer? And the answer was yes, all right? So the reason we buy colostrum replacer is to provide IGs to that calf in the absence of mom's colostrum. Well, what we find here is that, in fact, the colostrum replacer did, in fact, do that. But if you look at, and I'm just going to show right down here at the bottom, there were 2 different milk replacers, a non-plasma and a plasma-based milk replacer in each of these. But the bottom line here is to look at these feed efficiencies. The colostrum-fed calves had a feed efficiency, gained a feed of 0.4. The colostrum replacer calves had a feed efficiency of 0.24. Not quite half the feed efficiency, but significantly less. And that, to me, is quite dramatic. And again, since IG status is nearly similar or identical, because the colostrum replacer did, in fact, provide adequate IGs, what this points to is that there are things in colostrum that we might not find in, and this happens to be a serum-derived colostrum replacement. There were things in that serum-derived colostrum replacer that were not found in mom's milk or mom's colostrum, and that then those other factors, other than IGs, had an impact on how that calf performed, right? We followed some of this work up recently. One of my PhD students, Fernando Soberón, again, 2 or 4 liters of pooled colostrum within an hour of birth. We managed the colostrum quite intensively, made sure the bacteria counts were low, tested every batch. And then what we did is after we fed the colostrum, we put them on an automated feeder and either let the calves have ad libitum feeding or restricted feeding. So what we wanted to understand is if they have restricted feed availability, are they more feed efficient? Or if they have ad libitum access to feed, will they go to the feeder more often and just consume more? Right? And we just simply measured many things, but just very applied stuff is on this slide. And the best comparison, the first thing that we see here is that if we look at the IG concentrations, quite high for the high colostrum, significantly different for the low colostrum. That's what this L and L mean, and the first letter means low colostrum, H means high feeding, L means restricted feeding. These IG concentrations are actually above industry accepted norms. So passive transfer on this study, even for the 2 liters of colostrum, was quite adequate. I'm not going to focus on the low feeding levels though, because what we see is not much. We restricted them so much that we really didn't see enough calories to actually show enough advantage. But what's interesting is where we have high colostrum and high feeding and low colostrum and high feeding, we see a difference in wean weight. We see a difference in pre-weaning average daily gain. We actually see a difference in average daily gain up to 80 days. So post-weaning, average daily gain was different. They did consume more, about 8 pounds more dry matter if they were given a high level of colostrum. So that explains some of the growth rate, although 8 pounds over that many days won't explain all of that. And notice that we also found a significant increase in average daily gain post-weaning. All right, so from a management perspective, the low colostrum-fed calves that were offered a high level of feeding were more than adequate on IG status. Obviously not identical, so it's not as clean as it could possibly be. But the implication here is that the more colostrum we got into them, the more weight gain they had, the more feed efficiency they had, and actually that process was extended out into the post-weaning phase, which helps us explain possibly what went on in that previous study where they looked at the brown Swiss calves up through the second lactation. So again, just more evidence that what we do in that first feeding impacts growth rate, impacts intake, and it looks like this is a long-term effect, and we would suspect that this actually goes out into lactation, and that's a long-term study, and we'll see if we can get one of those done. So the colostrum take-home, there are compounds in colostrum that intake pre- and post-weaning feed efficiency somewhere between 12 and 50%. We don't know really if there's a lot of regulation of feed intake. We think regulation of feed intake or satiety is probably mostly influenced by colostrum in the post-weaning phase, but we think the 2 effects are probably for life. And I think coming back to the other species, the data from pigs suggests that there are possibilities of other developmental functions being affected by colostrum, and the one that they've identified first, the most important one to them so far, has been reproduction. So the idea that maybe we could influence the reproductive efficiency of our cows by enhancing colostrum intake or components within colostrum intake is very intriguing to us. So now I'm going to leave the colostrum topic and just jump into how we should think, or how we think about calves. And I have up here on the slide proactive calf program goals. And I did this. This slide came out of frustration. I remember going to many meetings and I was listening to my colleagues. I'd listen to Tom Overton or Jim Drakely. I could list lots of people stand up and talk about transition cows and fresh cows and high-producing cows. And they would all have these you must meet this, we must do this, we got to have this objective, they got to be eating this much, we want our VHVAs here. But they were all positive management objectives trying to improve productivity of these cows and reduce problems. And some of us would talk about calves, and we talked about morbidity and mortality and pretty sour things. And I said, we've got to have a different way to approach this. So I went back and I reviewed the literature. I looked at our data, I looked at many other studies and said, hey, I think a realistic goal is to at least double the birth weight. All right, and that's where this came from. It's just saying, hey, we gotta be like all other classes of dairy cattle and have some proactive goals, because we always make more money and make better decisions when we're being proactive than when we're being reactive. And I think that was one of my approaches to this thing. Right, we can talk about, so a 90-pound birth weight should be 180 pounds by about 56 days. If you're a Jersey and you're at 50 pounds, you should be 100 pounds. I was on a dairy in Minnesota a couple weeks ago. Great dairy, fantastic. They are tripling their birth weight by 60 days. All right, just fantastic. All right, awesome calves. All right, so this objective, in my mind, is quite approachable, and we have lots of dairies that are now exceeding this and telling me we need a new goal. Right, calf mortality less than 5%. There are herds where mortality runs less than 1%, so I know this is achievable. And calf morbidity less than 10%, and again, that's a modest goal. There are herds that are less. Sometimes treatments are higher than that. It depends on what you consider a treatment. Electrolytes for scours is one thing. Antibiotics is another, and we want to minimize the antibiotics, and I'll show you why here in a few minutes. We want to eliminate or minimize those types of events. Lots of reasons why we should do this. The one I'm going to talk about mostly today is potentially increased milk yield and herd life. There are, the feed efficiency is one that I think we've missed. We get focused on dollars per day, and I know milk replacer and milk are expensive items, are very costly. But once we get above maintenance, these calves are very, very efficient, right? So if we can get 2 or 3 times maintenance intake, those calves will reward you with tremendous growth. Now that brings along some other management concerns, like, can we do this in 2 times a day feeding, or do we have to move to 3 or multiple times a day feeding? And that may be true depending on how much you want those calves to eat. But they have tremendous feed efficiency in early life, and our program over the last 40 years has really not allowed us to capture that feed efficiency. But where we're going to spend most of our time today is on the increased milk yield. So here's the one slide on nutrient requirements. And this is of a 100-pound calf under thermoneutral conditions, so we're assuming no maintenance stress. And we can modify that, and we can talk about it, but you can see here that as we look at higher rates of gain, we're moving from 0.44 to 2.2 pounds a day. Here's the expected energy levels, and again, under thermoneutral conditions, these are the energy requirements to meet those growth rates. If the temperature is 20 degrees outside, then we're going to have to enhance that a lot, simply just to meet the maintenance requirements and then have enough energy left over for growth. And we actually know how to do that. The 2001 Dairy NRC has a nice model, a very good beginning model that allows us to make those evaluations, and I would suggest that if anybody's really interested, you can download that from the National Academy webpage. That would be a great place to start. We are working on enhancing that model and furthering that model, simply because since that was written, the group at University of Illinois with Jim Drakely, some work out of Virginia Tech with Bob James, and a few other groups have developed some data sets that allow us to enhance this and refine it, which is what you see in this table. So dry matter intakes accordingly would have to go up. Crude protein levels obviously would have to increase, and you can see, I think the point that I want to make here is there is no one protein level that fits all rates of gain, right? So just like milk production, if we expect higher milk production or want higher milk production, we have to feed more metabolizable protein. In this case, as we expect more gain, we have to feed more protein. So if you want to feed just above maintenance, right? That 18 to 20% protein, that 20/20 milk replacer actually does what it was designed to do. It will meet the basic requirements of the calf, not expecting a high level of gain, right? So we can be cost effective, meet those requirements, encourage her to eat dry feed and get her weaned, all right? So, and that program works very well, and you can see by these requirements that, that fits right in here. So just, maybe half a pound a day gain. But notice as we go to higher rates of gain, where you have to increase the food protein level, and that's, mom's milk on a dry matter basis is somewhere between 25 and 26%. For the average Holstein, for the average Jersey, it's going to be somewhere between 28 and 32, depending upon level of milk production. So, but what we see here is that if we want higher growth rates, we have to put more protein in there. And again, mom's milk is going to be up in this range, all right? So that makes sense that the calf would tell us that's how much we require, because that's kind of what mom puts out. And what's interesting is that the protein level required looks higher than mom's milk. Well, and that probably makes some sense to me because, 100,000 years ago, mom didn't make 100 pounds of milk. 100,000 years ago, mom probably made, 5, 10, 15 pounds of milk, maybe at peak. There's a lot more protein per unit of intake, and they got more nutrients. So what the calf is telling us is they still have a high requirement for protein, and we've just changed the cow quite a bit. So this also explains, though, why you see some of the milk replacers on the market that you see that are in that 25 to 28% food protein range. And those milk replacers are out there because they reflect these numbers from this table and the data that has been generated over the last few years. So we can come back to this, but the one point I will make is that if you want, in my mind, and I'll repeat this a few times, as we begin to understand this long-term effect, we need to make sure that the protein status of the calf is maintained. But first of all, we need to make sure that we have plenty of energy in the right form to drive growth and protein synthesis. But at the same time, we have to get enough protein into them, because many people have asked me, can I just feed twice as much 20/20? And you can, and you're going to have very happy calves, but they're not going to grow very well, and they're not going to be very feed efficient because the relationship between energy and protein is not high enough. Yes, you're going to feed more protein, but you're not going to feed high enough protein to meet the protein requirement to get the feed efficiency and the frame growth and the muscle growth that you want. And based on our data, I would tell you that you're not going to find the milk effect. Okay, so we need to drive protein synthesis, and we do that by meeting the protein requirements relative to the energy supply. And I think that's a really important point. And again, that's going to vary a little bit by summer versus winter, and we can come back to that discussion during the question and answer. So I think we're pretty good now at saying that we have a really nice database from around the world that talks about the effects of neonatal nutrition on productivity. We have more data demonstrating that early life nutrient intake has long-term impacts on productivity. We don't really understand the mechanism. I mean, I can't say that it's a gene or a group of genes. I don't think that's true yet. But if you study the data, it looks very clear that it's most likely related to protein synthesis. In other words, getting adequate energy in there, getting enough protein in there, just encouraging those calves to grow, doing whatever we can to encourage good growth. But it does force us to think differently about development, and brings in big words like epigenetics and programming. And again, I think part of this relates to, there's a lot of data in the literature now about fetal programming, and what that's true for humans as it is for animals. And I think what we're learning is that immediately after birth, all of the things that were going on during fetal development are still very much active, right? And we still have the potential to modulate or moderate whatever that was, or manipulate whatever that was, through colostrum, through good nutrition, through good management. And it's probably mom has been trying to send those signals. Anyhow, we just didn't think about what mom might be trying to tell the calf or the baby, because we know this to be true for humans. And our management probably kind of short-circuited that, well, I'll say that discussion. Mom was still trying to influence how the baby developed, but our management system probably kind of took that away for a while, and now we're trying to give it back. So I remember many years ago somebody asked me if you fed a calf better, it would make a better milk cow. And that question was just tremendous for me, because I had never really thought about that. We were trying to generate nutrient requirements for calves. I've never really thought about the long-term implication. But what that forced me to do was to basically run upstairs and start looking for data. And the first paper I saw was this paper published in the Journal of Dairy Science in 1998, where they had allowed the calves to suckle the dam multiple times a day. They were really studying the cows and frequent milking, but they actually followed the calves also through the first lactation, and they saw about 1,000 pounds more milk. You know, and I showed this around to a few people, and they said, "Hey, that's great, but probably, got to be a little careful there." But so I called some guys in Denmark and said, "Have you ever done a study like this? Or do you have any of this kind of data?" And they said, "Sure, we've done a couple." They sent the data over. This is the full Dare and Crone paper, 94, and same kind of study. They let the calves suckle the dam ad libitum, and that was about 3,000 pounds more milk. Well, John Foldair is now retired, but he's a very good scientist. He didn't know what to do with that data, so he actually, as a good scientist would do, he repeated it, right, with about 7 different treatments. There's some very interesting treatments in there. I took the average of them. So the average of the 7 treatments was about 1,143 pounds. So again, positive, not 3,000, but still quite significant. So if we take the average of those first 3 studies, it's about 1,740 pounds of milk, and those are mostly suckling milk feeding studies, and it would be about 1.6 to 2.3 gallons a day versus about a gallon a day for the control. So that's the difference in the milk. So not quite 2 times, but about 2 times as much milk to get that response. And I found this intriguing and said, gee, it looks like there's really something to this. So we better keep pushing. Then Jim Drakely at the University of Illinois did this nice study, milk replacer fed calves, 1.25, so the industry standard feeding rate versus 2.2 pounds of milk replacer powder a day for 42 days. So you have this control versus enhanced. Age of first calving, not tightly managed, 24/6, 25/4, that's okay. That's where the industry, well, actually a little better than the average industry values. Body weighted calving was nearly identical. Milk yield, about 1,800 pounds, very consistent with the previous data, 1,700, 1,800. What was interesting about this particular data was that they had some interactions. They only feed calves on studies during the summertime for various reasons. So they did it in 2 blocks. The first block, they got about a 3,000 pound response. The second block, they got about an 800 pound response. Both positive, but different. In conversation with Jim, he said, in that second block, we had a lot of scallops. And so we had some crypto problems, maybe some coccidiosis. We just couldn't seem to get that under control. So the implication there is that in that second block, they couldn't absorb as many nutrients, they were a little sicker. So that would explain, coming back to the idea of protein synthesis, that they just didn't get as much energy, didn't get as many nutrients, couldn't drive growth the same way. Still a positive response, but not as good as the year previous, where the calf health was much better. But on average, over the 2 blocks, 2 years, 1,800 pounds of milk. So again, notice that everything here is positive. So if you take the sum of the studies that are available, not all of these studies are fully published. Granted, they're not all fully published. Some of them are still in abstract form. Some of them are in conference proceedings or scientific conference proceedings. And we have them all listed here. I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 studies listed here. And we have the amount of milk that was observed in all those studies, and the S is significant, T is a trend, all the way through, non-significant. So not everyone's significant. but they're all positive. And as a good friend of mine, Bob Everett, would say, or used to tell me, he goes, if you can put up data like that, you don't really need to be a statistician. Bob was an animal breeder, so he was an excellent statistician. He would say, hey, I don't need to do a lot of statistics. If you can put up that many studies and show that kind of positive response over that many studies, that should be true. And that should be a real effect. And you can see here there's one study where there was no effect, and if you read the paper, the differences in calf growth were very, very modest. It was 150 grams a day, or maybe quite 200 grams a day. So half a pound at best difference in growth rate. So probably not enough difference in growth rate to stimulate the difference in milk yield. And they also had pastured the animals for a little bit, so it might be a little bit confounded. But when we look at the sum total of the data, it's all quite positive. And what we did is we took the data and we said, okay, there's new statistical approaches out there where you can do something like a meta-analysis, where you take the study and you call it random, and you weight by the number of animals per study, the number of animals per treatment, and you can actually include the variation within and among treatments. When we did all of that, then we asked the question from those 11 studies, just the yes or no question. Did calves that consume more milk or milk replacer make more milk as adults? And the answer was yes. Over 1,000 pounds more milk in the first lactation, highly significant. If we then add a continuous variable like average daily gain, pre-weaning average daily gain, and look at milk production, we could then get the unit of milk per unit of average daily gain, and that ended up being 1,400 pounds more milk in the first lactation per pound of pre-weaning average daily gain, highly significant. So if you take the sum total of all these studies and analyze them, given the variation presented in all of those studies with all the numbers of animals that were used, it's pretty clear cut now that we actually have a very nice response to faster growth rate, enhanced nutrient intake, more protein synthesis for long-term future productivity, right? And we think this is a real positive for the dairy industry. Ken Weigel and I from the University of Wisconsin, we've gone back and forth on the nature versus nurture thing. You know, he'll say, well, as a geneticist, I can make the decision, I can breed the cow, I don't have to worry about that again for the rest of the animal's life. You have to measure it every day. And I say, yeah, but it might be worth, my effect might be worth more than yours. And I'll come back to that in a little bit. So it's been kind of a fun discussion about nature versus nurture. You know, does this make us any money? Well, if we look at the average milk yield response, it's about 1,700 pounds. As somebody who promotes technology, to me, this is very similar to an average BST response in first lactation cattle. I mean, apparently the industry and or the consumer doesn't like us using some of these technologies, so in certain markets we're losing this ability. So the question is, well, if we can't use that technology or that management tool, how do we get that milk back, or how do we find more milk? And it looks like feeding calves better will get us an equivalent amount of milk. You know, and if we look at, we did some calculations at $15 hundredweight milk, it's about $255. At least when we made this calculation, at $18 per hundredweight milk, it's about $306 increased income for the first lactation, and then we have to calculate out our costs, and we'll come back to that. So we took a different approach at Cornell. We had accumulated lots of data in our own herd because we've been doing this kind of feeding for a very long time. And again, with one of my collaborators, Bob Everett, he helped me think through some of the mathematics and how we might use the same tool that you would use to do sire summaries to evaluate this effect. So we used Bob's testing model to evaluate calf growth and long-term performance. And as I said, the testing model is simply a method of evaluating milk production, fat, protein, and somatic cell count. More accurately, it can be done using 305-day MEs, and it accounts for lots of variables: test day, age, states of lactation, pregnancy, month of calving, and it does a residual analysis, so we don't have to spend a lot of time on that. But it's the same type of process, the same mathematical procedure that would be used to generate sire summaries, predict the transmitting abilities, estimate heritabilities, and look at other production traits. So the math is pretty robust. This is not a controlled study, but the beauty of the mathematics is it allows us to use each animal against one another, and that is exactly how we used it, because that's kind of how you do a sire summary, because you don't always have a lot of control in a herd when you're evaluating bulls, daughters, and things of that nature in cows. So in the Cornell Herd, we started feeding for over 2 pounds of pre-weaning average daily gain in 1988, and that was actually Larry Chase's decision. Larry had been watching the calves we had in the research barn, and we could go out and look at the hutch calves, and he said, hey, why can't we do the same for the research calves in the hutch calves and for the herd calves? And I said, that's a great idea. But that was Larry's decision, because he was the one making all the nutrition decisions on the farm at the time. And then we had some good staff at the research farm that have helped us track some of the numbers. So we have over 1,200 first lactations. We have 8 years of data. We also have the growth data from those animals. Not all of it that we'd like, but we have all the pre-weaning data up to weaning, the growth rates. And the simple question that we asked, does any farm-level calf measurement have any relationship to first lactation milk yield? So we looked at birth weight, weaning weight, average gain until weaning, gain in hip height, and gain in wither height. On a commercial farm, they actually had the pre-pupal average daily gain numbers, so we went up to that farm and used their information and analyzed their herd. And in our herd, we actually we knew what each calf consumed. We knew what the daily temperatures were over all those 8 years. So we actually used that to calculate maintenance requirements and looked at intake over maintenance for milk replacement. All right, and here's where you realize that the Cornell herd is a real dairy herd, and this looks like really interesting data. And you say, wow, So the range in growth rate in our data set was 0.23 to 3.5 pounds per day to weaning. You look at that and you go, okay, is that good or bad? The problem is that very few of us actually have that much data on calves, so we don't really know what a normal range would look like. And I can tell you from measuring lots of calves on many farms, that is not unusual. You've got some that just don't grow for various reasons. We've got some that grow like crazy and are very feed efficient and love starter and can't eat enough, right? But in a conversation one day with Jim Drakely, he said, Mike, he said, it's really interesting, your data. He says, but I don't understand it. He goes, if you have such a great feeding program at your research farm, why do you have such a range in growth rate, right? And I said, I don't really have a good answer for you. I said, I'm assuming that some of that has to do with colostrum status, and we don't know the colostrum status of all of these calves. And as I just pointed out, that's important. We also, actually, in the next question, why the range and growth rate of the program is the same year-round? Well, that actually is the answer to the question. Even though we feed twice as much milk replacer as has been the industry standard, we feed the same amount in July as we do in January. And what we realized after that question and after that discussion is that even though we're above maintenance in January, we're not as high above maintenance on nutrient intake as we are in July or the warmer months. Therefore, growth rates actually go down in the winter time. Still positive, but they go down, and they go up when the temperatures drop. So actually, that was a great learning opportunity as we pondered that question to understand where the variations come from. Again, there's colostrum buried in there, but we can't sort that one out because we don't have the data. So 305-day milk yield. So just to analyze the herd in a way that every other researcher would do if they had this data, we said, okay, we're going to take the 305-day milk yield data and regress that on growth and look at the effect of just growth rate and milk yield as everybody else would do it and find out if it was significant. So we looked at year of calving and average daily gain, and those were highly significant, and so was growth. And now just using standard milk yield, just like everybody else would do, for every pound of average daily gain prior to weaning, milk yield increased by 706 pounds in the first lactation. So again, significant across all the data. That's great because it means that the same effect that everybody else has seen, we can identify also. but we had multiple years of seasonal variation, feed variation, management variation. It is a research farm, so there's lots of that going on to possibly give us a little bit of not confounding, but just noise. So we wanted to use a test day model, and that's what we did here. And this slide actually is just to show that, because one of the other questions was how the animals came about. So there's the 1244 in the first lactation. These 826 animals in the second lactation, because see, we have multiple lactations now, not just the first. These 826 animals came out of the 1244. The 450 animals that we could get data on came out of the 826. Okay, so these are the animals that we had the ability to follow for up to 3 lactations. One question that we had and that we wanted to make sure is that there was no bias in the data. In other words, these 450, we wanted to make sure we're not at the extreme of the bell curve during their first lactation, and in fact that they actually were in the same group. In other words, that they weren't at the extremes high or low of the milk production of the groups, and actually they weren't. So the average of the residuals, and the residuals for the first lactation, all residuals have to sum to 0, so it's not unusual to see negative residuals for first lactation animals compared to the rest of the herd. So the 1244 is minus 282. In the second lactation, these animals, actually in the first lactation, had a minus 315. These 450 actually had a minus 377. So overall, these 282, so what this is saying is that there's no bias in this data set, that these were not the extreme producers in the first lactation, and that's why they're still here, right? You can see that they did tend to make more milk in that first lactation. This is the extra milk per pound of average daily gain. Overall, it was 849. These guys have to have 941. These guys 1100. So there may be some indication there. But if you actually look at the population as a whole, there was no bias, and we just listed that all the way out to the third lactation just so everybody could see the data. So we did test this for confounding and bias. We wanted to make sure that there wasn't any, in our minds, there was no bias there. So when we look at the data that we were really interested in, this is the effect of and we say predicted difference because we used a statistical approach like you would a SIRE summary. So the difference in milk yield per pound of average daily gain. So the first lactation, it was 849 pounds of milk for every pound of average daily gain, highly significant. Most intriguing, those 826 animals, we can find the same effect in the second lactation, and then it was 888 pounds of milk for every pound of pre-weaning gain in the second lactation, highly significant. In the third lactation, we tend to lose the effect. It's still positive at 48 pounds, but it's non-significant. When I'm trying to be funny, I blame it on Dr. Tom Overton because of all of his transition cow studies, but that's probably not fair. But what we see here is, he only uses the second lactation cows. What we see here on first to third, though, if we look at all over the lifetime of those animals, those 450 animals, it's a little over 2,000 pounds of milk per pound of average daily gain, highly significant. So what we learned in this analysis, in this particular herd under our conditions, yes, we get the first lactation response, but not only is it a first lactation response, it's a second lactation response, and overall, it's really a lifetime response. So what we now know about this early life nutrition and management is that it's not just a first lactation response. We're setting these calves up for life. So this is the test day model residual milk by temperature at birth. All right, this is in kilos, and I'm sorry this slide happens to be in Celsius, but you know, this is 32 degrees Fahrenheit here. All right, and this would be up in the 70s here. And you can see what happens, and this is a direct result of that data, the spread in the data that we saw in the growth rate and the questions by Dr. Drakely. Why do you see that kind of a range in growth rate, and what does that mean? Well, I think this is what it means. In the wintertime, we don't change our feed intake. We still feed, you know, a little over 2 pounds of milk replacer powder a day. but it's not enough over maintenance to stimulate as much growth as we would like, right? Again, a great learning opportunity. And what it says is those calves born in the wintertime make less milk, right? And actually calves here, right, this is the relative temperature at birth, because, you know, we had all the temperatures at birth, we had all their temperatures to the growth phase, we knew their milk replacer intake. So this is the milk production by the temperature of birth reflecting their maintenance requirements. And we can see that when it gets warm outside, they actually do better. And as they start to get heat stress, they actually lose a little bit more. And this difference here is, you know, about 800 to 900 pounds of milk. And what we think is that we can probably manipulate this, and if we gave them more calories in the wintertime, excuse me, if we gave them more calories in the wintertime, we could actually move this bar up, and we could level this effect, right? So what it means is we have to pay better attention to our wintertime feeding to make sure we get the right type of calories and the right amount of calories into those calves to encourage more growth, to get more protein synthesis, so we think we can get this milk response. So the way and I think this is probably the most powerful way to use this data, is that given all the information we had, we actually created, we looked at the difference in milk yield for every mcal of energy above maintenance, right? So the same 1,244 animals, and instead of looking at it as pounds a day gain, we looked at it as mcals over maintenance, and it was 518 pounds of milk for every mcal over maintenance, highly significant. Second lactation, not sure what happened, still positive, but not significant. Again, back to maybe a research function, we're not quite sure. Third lactation, 450 animals, highly significant, right? 774 pounds. And if you look over again, those 450 animals where we went first to third, it's almost 2,000 pounds of milk for every pound or every mcal over maintenance, highly significant. So again, lifetime response. This to me is real easy to manage, because here you can just look at, you can calculate the maintenance requirement and say, hey, no matter what month of the year it is, I've got to be feeding at 2 or 3 times maintenance intake to ensure that I get the right kind of growth so I can ensure long-term productivity. So this was probably the most profound thing that my colleague Bob Everett came up with. Bob had studied animal genetics for 40 years. And, you know, he said to me, Mike, he said, in all my 40 years, I've never expected to see this much of the variation in milk yield, first lactation milk yield, accounted by anything. And he goes, it was astounding to him that he could explain 22% of the variation of first lactation milk yield simply by growth rate up to about 42 to 49 days. and that, you know, Bob's not with us anymore, but you know, a lot of our conversations center around what does this mean? Again, the nature versus nurture idea, in that, you know, if you look at just selection for milk, that only accounts for about 7% of the variation in milk yield. So growth rate is worth about 3 times as much as the selection for milk, right? And we think there's a lot of opportunity here, and it means that there's more growth and more variation to be accounted for, and we can do more with this particular variable. And I think what this means is, you know, and again, the effective growth rate and nutrient intake prior to weaning has a more direct and significant effect on milk yield than genetic selection for production. It doesn't mean we should stop selecting for milk yield. It means just the opposite. What it means is, as we select for milk yield, we better treat the offspring better, so they will give that milk response back to us, because we can't change their DNA, but it looks like we can enhance the way they express it, right? Because for genetic selection, the average calf or the average genetic selection yields about, you know, roughly 200 pounds of milk per lactation. Well, what we see here is, so maybe over 3 lactations, that's 600 pounds of milk. Well, what we now know is pre-weaning calf nutrition and management can be 4 to 8 times more milk than genetic selection. So once we make a more genetically superior animal, we need to treat them better so they perform that way, right? And it's just saying that mom wants to make the next generation better. We do part of that through DNA, but we also do a lot of that and even more of that through management. You know, and we know this. If you stop and think about what % of a cow's production is due to genetics and what percent is due to management, you know, the numbers vary a little bit, but we know that 20 to 30% of milk yield is due to genetics, which means 70 to 80% of milk yield is due to environment, right? And this looks like it's one of the significant environmental factors, and it's very early in life, and I think that's what we're finally getting to. All right, what about sickness, treatments, and growth? In the process of writing the paper, one of the questions came back from a reviewer. It was a great question. We hadn't considered this. If the calves got sick, did it affect their milk yield? Right, and again, this is a research farm, but we manage it like a commercial farm, so we don't record absolutely everything every day on the calves that we're feeding, just as herd replacements, but we do keep reasonable records. So by SOP, again, we went to our dairy comp, which is where we keep our records, and by SOP, diarrhea does not require antibiotics, only electrolytes. By SOP, antibiotics are primarily provided for respiratory illness. So the rest of the conversation is related to how we perceive the use of the SOP to treat. So what we learned here is that, so we went back and we asked the question, did calves with diarrhea have reduced growth? And yes, they did, 30 grams, but it was not significant, so a very small amount. But for calves that had both events recorded, average daily gain was lower by about 50 grams a day, and that was highly significant. When we analyzed this effect on milk yield, we saw no effect of diarrhea on first lactation milk yield. However, the calves treated with antibiotics produced about 1,000 pounds less milk in the first lactation than calves with no record of being treated with antibiotics. Well, so what does this mean? In our minds, what this means is we don't have calves that come to lactation with, you know, scarred lung tissue and problems like that. What we believe this means is that, like, when we all get sick, we don't eat as much, right? And again, back to the idea that protein synthesis is important and nutrient intake is important and maintaining those growth rates are important. This, to me, says if we have to treat the calf with antibiotics and she has a respiratory disease or a disorder at the moment, and she probably has a fever or may have a fever, which means she's probably not eating as much, it means our growth rates are reduced, right? And it takes them several weeks to get over that. And if our window of opportunity are those first 4 to 6 weeks of life, and she happens to get some problem in the middle where we have to treat her, that's going to take away from that opportunity to optimize or maximize the growth. Okay, so and where this goes though is that we looked at this growth rate. So calves, so regardless though of antibiotic treatment, we could still observe the positive effect of average daily gain in milk yield that was highly significant. So even though the calves that were treated with antibiotics produced less milk, they still produced over 600 pounds more milk per pound of pre-weaning average daily gain. However, the calves not provided antibiotics produced 1,400 pounds more milk per pound of pre-weaning average daily gain, right? So there's at least, 600, 700, 800 pounds more milk for the calves that weren't treated with antibiotics. All right, so maintaining health, minimizing antibiotic treatment, minimizing respiratory disease, keeping them on feed, all those things are really important to get this long-term response, okay? And we were able to separate that out in our data. If we looked at the commercial farm, this is 4 years of data from a herd in northern New York. This is a 30,000-pound herd. This is a very, very well-managed herd. They use a very similar milk replacer to what we have and have a very similar feeding program. We've been working with them for years, so we understood this. Again, data like this are very hard to come by. We scrutinize the data very strongly. In our data set, the only animals that were analyzed for lactation were animals that we had growth data on, and that's the same here. So the only animals analyzed here for lactation data are the same animals that we had growth rate data on. So we didn't just analyze the herd and then look at the milk production. Each animal is its own control in both of these data sets. I think it's a really important point because I think some people have confused that. So in this particular data set, 623 animals for every pound of average daily gain prior to weaning, 1,114 pounds of milk, highly significant. If we look at it from weaning to breeding, we actually see a positive response. Also, we did not anticipate this. Right? This leads to all sorts of other ideas because basically this says that the pre-weaning or the pre-pubertal growth rate is actually positively related to milk here, which is contrary to about 40 years of data. And what I think this means is if we feed them better as calves, then that sets them up to be better in whatever way you want to define better, but better milk producers. Thus, post-weaning average daily gain is actually not a negative, it's a positive because we established all that frame growth and we established all that muscle tissue early in life, and they can build on that as we move into that post-wean pre-breeding phase. Second, lactation. This herd has some sophomore slump. We could see that here. Saw a negative residual, not significant. Just says that I think, the 30,000 pound herd, they're calving at about 21 months of age, doing really well in the first lactation, probably could grow them up a little bit more to manage the second lactation. But again, this is a very high producing herd. But notice if we look at average daily gain from weaning to breeding, highly positive, 1,500 pounds of milk, highly significant. Third lactation, positive, not significant. Again, positive. What I really want to get across to you here, aside from that second lactation, there are no negatives, right? And their age of first calving is 21 months or less. So on 30,000 pounds of milk. So this is a really very good performing herd. This also says that it's probably not going to be the same response for every herd. There are going to be a little bit of variation here, and this is where we have to develop systems to help us analyze what this means to optimize the response. Very quickly here, just to wrap up, Mike Overton at the University of Georgia has actually just recently updated this analysis, but this is the one that he shared with me because the question's been asked, in his mind, conventional versus intensive. If you put all this money into a calf, does it pay back? All right. So these are the slides I borrowed from Mike. He presented this last week in a meeting I was at with some updated values, very similar numbers, just a little cleaner data set. So $250 calf, 8% interest, $18 milk. So initial cash value of $250. Here's the conventional system. Here's what he calls the accelerated system. And if you put in that 1,700 pounds, well, first of all, if you look at average daily gain, 152 versus 198, age of first calving is about 2.7 months difference in the two systems. So a little bit difference in average daily gain. The actual cost per day is going to be higher because we're putting more nutrients into these guys to get them to grow faster. If you put that 1,700 pound additional first lactation milk yield in there with a culling risk, the advantage actually is to the accelerated animals by $231. And he broke out the cost. The feed costs are higher, labor's less, health and vet med are less, interest costs are less, reproductive culls are less, other costs are lower, total dead calf costs are lower, so you're reducing your cost by about $51. And if you add in the value of the milk in this initial evaluation, it was $231 to the positive in the net return, which is quite high actually when you think about net farm income per cow in New York. That's actually over half. If we look at, it's over half the current value. If we look at some data same kind of data we did here in New York, we looked at cost per pound of gain. This is with some help from Jason Carthy's pre-weaning cost per pound of gain. It was higher with the intensified or whatever term you want to put on it. Pre-weaning average daily gain was higher. Age of first calving was about 22 months, a couple months lower than the comparison. Overall average daily gain from birth held them at the same body weight at calving. Looked at non-completion rate, slightly better. For the intensified animals, we didn't lose as many. Here's your total cost, total investment, right? So pretty similar because of the higher feed cost. But when we look at, we put a net present value discount on the milk income, again, assuming 1,700 pound increase in first lactation milk, the change in time to calving, our value for the net profit increase was about $201 per lactating heifer. So Overton's data from some Western data sets and our data from the New York data sets, we're both in that net profit increase of about $200 for this concept. All right, so just to summarize, what we now seem to believe here is that nutrient intake in early life impacts lactation milk yield. All the data are positive. There's one neutral data set. The mechanisms we really don't understand. We think it's related to protein synthesis. We've got a little more work to do to really nail that down, but we've got the long-term effects, right? We know that it's there. A lot of the data will show us that. The data very clearly demonstrate that early life management enhances the effect of genetic selection for milk yield, right? I think that's the most intriguing thing here is we can modify how they express their genetic potential through colostrum and early life nutrition. So, it looks like we can make profit doing this also. And with that, I'll take any questions.
Very good, Mike. Maybe you can click on to our next PowerPoint if you can on your end there. And Steve, maybe we'll turn it back to you if you want to make some quick comments for the next series of webinars in our hosting.
Right, Mike, and then we'll get back to you with some questions here. Again, first of all, Mike Van Haar, thank you so much for a great presentation. And Ben Amburgh, excuse me, I'm getting my mics mixed up here. I apologize for that. Thank you so much for a great presentation, very well organized and very well presented, very impressive. And we also want to take this opportunity to thank again the folks at Merck Animal Health for their sponsorship of this. Coming up, for those of you that are viewing this June 11th, Jim Drackley on feeding and handling of transition cows, sponsored by Elanco. And then a month later, Mike Hutchins' new looks at corn silage utilization for dairy rations, sponsored by Biotol forage inoculants. And with those forecasts, Mike, back to you for some questions.
Very good. Mike, can you hit us one more PowerPoint and we'll let our sponsors pop up there because without them, we could not do the webinars. Mike, we have a couple questions that came in here. First one, you mentioned about the benefits of things in colostrum. Are there any benefits for feeding the transition colostrum milk days 2, 3, 4, 5, or 6 after in terms of immune response?
Yes. So there are some pretty good data out of Europe on this. Faculty member by the name of Jörg Blum has done hundreds of studies on colostrum in calves, mostly all short term. And from his recommendations and the data that we have, we would say yes, transition milk is a great thing to feed the calves, primarily because it still contains some antibodies in it. And even though the calf is not going to absorb those antibodies, what it does do is it helps clean out the gastrointestinal system. So it helps clean the gut out because the calf is going to begin very early in life to be exposed to all sorts of pathogens and bacteria. And so feeding some of that second colostrum and that waste milk over a couple days, and even more colostrum for 2 to maybe 4 days is a real positive thing to help maintain gut health and get that calf off to a good start. The data that the European data would say probably not much beyond 4 days, simply because if we continue feeding that, then the calf actually doesn't gain that much exposure because we're keeping the gut clean, and they don't start to build enough antibodies, and that may put them at risk by the time we wean them. All right, so 4 days is good. Maybe you want to stop after that and let the calf start to gain some natural exposure.
Mike, another question that's come up on our screen here. You mentioned the right kinds of milk replacers here. You mentioned the protein. What about fat levels, or if I'm buying a milk replacer, what should I be looking for on the tag?
Yeah, good question. I think it comes down to what are your expectations for growth. And I won't go back to that slide. Everybody can do that on their own. But if you want 1.5 pounds of growth or higher, and I would say if you want to double the birth weight, which is where a lot of people are at, or what people are starting to target, then you're going to have a milk replacer that's in that 26 to 28% crude protein range. And then the fat's going to vary by season. And this has been a hard thing because milk replacer companies don't want to have lots of excess inventory, but they are starting to think about wintertime conditions. I think we have enough data now to make them do that, or to help them do that. Can't make them do that, but we can help them think through it. And what that means is, I think in the summertime, 15% fat, 20% fat's okay. I mean, the reality is the calf could actually get by on probably 10% fat in the summertime when there's plenty of warmth. But as the temperatures start to drop and we start getting below that, the thermoneutral zone is between 68 and 82. So as our temperature starts to drop below 68, those young calves are actually cold stressed. And as that temperature continues to drop below 68, we actually have to increase the amount of fat in that milk replacer. So I would suggest that in the wintertime, you'd want to be running in that at least 25% fat on a milk replacer. And I could argue that in the really cold environments, northern New York, Minnesota, places in Wisconsin, upper Michigan, where it gets pretty darn cold, we may even think about a 30% fat. Right? Got to have the right fatty acid profile. And the reason I say this is that we learned that calves can't make fat from carbohydrate. Right? They're very lucky that way. They can eat all the pasta in the world and they wouldn't get fat. But we obviously, so they do need some fat. And as it gets cold outside, they will burn those fat calories to maintain body temperature and use the carbohydrate calories for growth. All right. So as we get colder outside, we got to increase the fat so they are burning the carbohydrates and the proteins to stay warm, and that actually will optimize our growth rate.
Mike, there was another question here regarding jerseys. You're using somewhere around 1,700 pounds of for first lactation advantage. I assume most of that is Holstein data. What would you expect with jerseys?
I would expect, obviously, we're probably not going to get 1,700 pounds, but I would expect jerseys to be, the average jersey is probably running about 70%, 60 to 70% of Holstein production. If you just look at fluid milk output, not energy-corrected milk. So I would expect a similar type of response from jerseys. So maybe 1,000 to 1,200 pounds would not be unusual in a mature jersey.
Mm-hmm. Okay, thank you. The question I had was, in your analysis, what replacer costs did you use for the conventional and the intensified on a per pound or per ton basis? Do you recall?
That's a good question. I think at the time we used maybe somewhere between 80 and 90 cents a pound for the traditional, and about $1.10 a pound for the intensified.
Okay.
But there was a at least 20 to 30 cents a pound spread in the value. I do know that.
Okay, that'd be about a normal difference.
Yeah.
Okay, thank you.
We have another question here. Someone said you mentioned doubling calf weight, then you visited this new farm, triple. Do you think you have the right number? Maybe triple is better than double, or is it 1.5 or 2.5? Any thoughts on that?
Great question. Yeah, well, so I'll come back to the data. So we actually asked that question while we were putting the data set together. And as we analyzed our data and the commercial herd and some of the other data sets actually that I shared with you, we can't find a plateau. Right? So the faster we can make a calf grow, it looks like the more milk she's going to make, which is why I think the simple way to think about this is just protein synthesis and growth, and synthesis and growth. So tripling, is that good? Based on the data we have, I would say that's fantastic. Can people manage that? Maybe not today. Would I like to revise the objective in a few years? Sure. I'd like to be able to say, you know what, we can get to tripling the birth weight. Right now, I think if we can get most of the industry to go to doubling the birth weight, we're going to be great. and that would be fantastic. And I think that's going to get everybody some milk. So yeah, but I think the fact that we can't find an upper limit relationship between growth rate and milk yield is pretty telling to me, and it says we have much more opportunity.
Another quick question, this is the last one I've got on my end here, Steve, and that is looking at do we need to then go to 3x milking if we're going to go to these more accelerated rates? And what about these robotic feeders? Is that going to be the solution for accelerated growth where calves can consume 4 to 6 times a day?
Yeah, I think if we're going to get the new, and I think that is a great question, and that's one that we're struggling with the management of and the cost of. 15 years ago, we suggested to all the New York dairies that they should, not all of them, but we suggested to our New York dairy producers that they should move to 3-time-a-day feeding, and they all laughed at us and said that's too expensive, we can't afford the labor. But a lot of them have moved that direction since then for all sorts of reasons. So yes, I think if we're gonna try to double and triple the birth rates, you cannot do that consistently on twice-a-day feeding. There's too much volume of milk. We have done it. A lot of our calves in our research have been 2 times a day. We moved to 3 times a day, and now we have an auto feeder for various reasons. We have a couple of them, but yes, we're going to have to move to multiple time-a-day feeding. Actually, there's a nice study out of Wisconsin. Don Sockett presented it last year at ADSA, where he actually fed the same volume of milk replacer in 2 versus 3-time-a-day feeding, and actually moving to 3-time-a-day feeding, he picked up about 7 to 10% increase in feed efficiency, which is something we've also observed, but he followed them all the way out to lactation, and those that were fed 3 times a day actually made more milk. So that feed efficiency by feeding more often actually translated into more milk yield when they got to lactation. So yes, I think that eventually we're going to have to figure out how to get more feed into calves by feeding more often, and that's just natural, right? We don't force feed babies twice a day, our human babies, and say, hey, you're going to be happy with that. And we don't do that to us either, right? So as far as auto feeders, I think they're great technology. They don't absolve you of calf management. What they do is they free up your time to actually manage the calves, right? They're going to do the feeding for you. They're going to do the washing for you. Actually, they're going to collect some data for you because you can get scales with them. You can get growth rates, you can get feeding frequencies. That's actually how we use it. That's helping us understand feeding behavior and feed efficiencies. And it's also, we can print out a report every day that tells us, hey, if calf 2 it likes to go to the feeder about 12 to 15 times a day, and yesterday she only went 3, we already know, we don't have to do anything else. We just have to walk out and find that calf and say, okay, what's wrong with you because you didn't come looking for food yesterday. And she might not even look clinically ill, but we know something's going on. So those technologies actually can be quite useful management tools.
Well, Steve, that's all the questions we have on our end here. I'll turn the program back to you.
Well, thank you, Mike. And again, Mike Van Amburgh at Cornell, thank you so much for a wonderful job, and also our thanks to Merck Animal Health for their sponsorship. Just a reminder to those viewing this webinar that all of the webinars are posted on our archives, hoards.com, and then click on the webinar series, and you can view them all at no cost at your convenience, and be sure to share that with your coworkers as well, and we look forward to having you with us again on future webinars.